Notice, and this is a regular copyright. Mathematics syllabus, effective May-June 2018, and runs up to 2027 normally. Subscription to full CSEC math course. Now, the math syllabus is divided into 9 sections. As you could see here, the 9 sections. Section 1, I have divided into 32 videos, and all these 32 videos will be made available on YouTube in their entirety. This section forms the foundation on which the rest of the syllabus is based. How well you can handle this section will predict how well you will do with the rest of the syllabus. So if you could deal with section 1 very nicely, it means that you could handle the other sections as well. You can then decide if you want to sign up for the subscription channel. And by the way, all the other mathematics videos will be partially available on YouTube. Now, the paid subscription site will require a reasonable monthly fee. There will only be a limited amount of persons who can subscribe at any one time because of bandwidth concerns. You can unsubscribe at any time by just not paying the monthly fee. The CSEC Mathematics exam consists of 3 papers. Paper 1, 60 multiple choice questions. Paper 2, in 2 sections, you have assortments of structured questions. And paper 3 is an SBA. If you are in school, you have to do an SBA. Or if you are not in school and you are writing it as a private candidate, you have to do an alternative to paper 3, which is based on the similar things that the students would have done in school for the SBA. All the papers of the exam will include a formula sheet. Silent electronic non-programmable calculators are permitted, note this, in papers 2 and 3, but not in paper 1. And that brings us to one extremely important caveat. It means that you will need to know the times tables from 2 to 12 if you hope to pass this exam. This is what we were familiar with from primary school, the times table, the multiplication times table. And some of you may have seen this version of that same table. This version of that same table means the same thing. Multiplication. Now, as it relates to the subscription channel for the entire course, let me be quite clear about it. Most students in school do not need to go that route. If you pay attention to your math classes in school, if you do the in-class work, and if you do the take-home assignments, you will not need to pay this extra money for similar teaching or learning experience online. However, if you are a working adult who still needs to pass CSEC Math, you may find this subscription channel useful. You will also need to purchase 1 or 2 math textbooks that were written specifically for CSEC Math, which the Forms 4 and 5 students would normally use in regular classes. The syllabus has some recommendations, and the one I find most important here is An example of a very good two-volume set of math textbooks recommended by CSEC. There is volume 1, and then there is volume 2. Please note a disclaimer here. I get no financial benefits from the sale of these books. Just saying. Now, before we continue, just to be clear, if you intend to study for and then write CSEC mathematics examination after a year or two, if you don't already know the multiplication tables, you will have to learn them by the time you are ready to write exam. And two, you will also need to buy a CSEC math textbook, 1 or 2, to get more practice, and you will also be able to check your answers at the back of the book to see that you are on the right track. So you have to do those 2 things. Now, schedule of videos. Right now, I am starting with video 1 of section 1, and this has 32 videos, as we will see subsequently. I'm hoping to get all of that done in September of 2024. As I said, this is the most important and crucial part of your syllabus. Then section 2, consumer arithmetic. I'll try to get that done in October 24, 13 to 15 videos. Section 3, sets, no more than 10 videos. We'll probably get that done in November of this year. And then measurement, which is a bit complicated, 16 to 18 videos, and we'll try to get that done in December 2024. So by the end of the year, 2024, hopefully, we will have these 4 sections covered. And then next year, January 2025, statistics, February 2025, algebra, March 2025, relations, functions, and graphs, and April 2025, geometry and trigonometry. Most of that is already done, but I wouldn't put them up until April. And then we have vectors and matrices, the last part, scheduled for May 2025, but I will try to get this section done by April 2025 for those who are thinking of writing exam next year and need this information. So as I said, section 1, number theory and computation. I have divided it into 32 videos, all of which will be made available on YouTube. So here are the 32 videos. Let's take a closer look at that. We begin with sets of numbers, types of numbers. We go right down to base 10, video 16. And then for video 17 to 32, video 17, base 2, base 4, and base 8, video 18, and so on. Objective 16 and 17, more on number sequence, video 31. And finally, ratio and proportion, video 32. So this is the largest part of the syllabus that you have to do. Remember, it covers forms 1 to forms 3 work in secondary school. So we begin with section 1, video 1 of 32. Distinguish among sets of numbers. Now, there are various ways to subdivide any group, especially a large group, of somewhat similar entities based on specific characteristics. One of the simplest everyday examples is pets. The most common subdivision of pets would be dogs and cats. But then dogs can be further subdivided into large dogs and small dogs. And then the large dogs can further be subdivided into various breeds of large dogs. Example, Great Dane, Saint Bernard, Burmese Mountain Dog, German Shepherd, Alaskan Malamute, Doberman, just to name some of the most popular ones. This can be done with any large number of items or entities. Example, people, fish, trees, microbes, programming languages, computers, and so on. And it can be done for numbers too. Now, the groups may not be exclusive. Sometimes there would be overlap. This is a print screen from the syllabus, which is objective 1, distinguish among sets of numbers. And we will be talking about natural numbers n, whole numbers w, integers z, rational numbers q, and then we'll be talking about irrational numbers, that would be f, not listed here. And then we'll be talking about real numbers, which comprise everything you see here. So distinguish among sets of numbers. As I said, we want to know what are natural numbers, what are whole numbers, what are integers, what are rational numbers. We will look at these in detail. We will also briefly look at irrational numbers, and all of those numbers together make up the set of real numbers. So it's a union of rational and irrational numbers. We will go that over back in detail right now. Distinguish among sets of numbers. So we are dividing this one objective into 4 videos. And the first one is sets of numbers. Sets of numbers. If we base numbers on their historical usage and discovery and development, you find that the original set of numbers that people began using were the numbers we use to count items. And these numbers are called natural numbers. They are all assigned the symbol n, and the natural numbers are the counting numbers. So n would be the set of numbers 1, 2, 3, 4, 5, 6, 7, and so on. Note that 0 is not included in n. Your syllabus defines natural numbers as the set of counting numbers. That is, n is set of numbers 1, 2, 3, 4, and so on. That is from your syllabus. If you need to learn a definition for natural numbers, please learn this definition. So the natural numbers, n, are the counting numbers. 4 set of numbers that were discovered and used. We could put it in a little circle like that. N, set of natural numbers. Now, if we were to include 0, which is extremely important in our calculation, with the natural numbers, then we now have the whole number group, which includes 0 plus the natural numbers. So the natural numbers, again, are counting numbers. Whole numbers would include the 0 and the counting numbers. So if we were to put them in a diagram, we could see that all natural numbers are part of the whole number group, but 0 that is part of the whole number group is not part of the natural numbers. Now, you know that pure water freezes at 0 degrees Celsius. If you were to cool that ice even further, what temperature will you get? Well, it will drop to -1, and then -2, and -3. So now we have been introduced to negative numbers. Previously, we were just dealing with 0 and the counting numbers. Now, if we were to include the negative numbers with the whole numbers, then the new group is called integers. and it is given the symbol Z. So Z would have all the negative whole numbers, it would have 0, and it would have all the positive whole numbers. That would be integers. So if you put integer in that diagram, the integers would be out here, the negative whole numbers, and in the integer you would have the whole numbers, and in the whole numbers you have the natural numbers. Your syllabus defined integers as the set consisting of positive and negative whole numbers and 0. And they give an example. Z is equal to the set -2, -1, 0, 1, 2, and so on. Now we will return to this diagram shortly. But for now, we know what integers are, we know what the whole numbers are, we know what the natural numbers are. The next stage was the discovery and use of fractions. We have terminating decimals and recurring decimals. Now, don't let that confuse you. I said fractions, and we think of fractions as one thing, and then I go on to say terminating decimals and recurring decimals, which indicate that decimals are also fractions, which they are. So if you find this video useful and interesting, please like and share. So like, share. You may also consider subscribing to this channel. Now, the next stage of discovery was the use of fractions. And we talk about recurring and terminating fractions. Now, let us say we have a cake like this and we cut it in exactly 2 equal parts. Cut it down like this. Now, one part, this part over here, you know that is 1 out of 2. You write it like this. But you normally say that is half of the cake. Now, if you divide the top number, the 1, by the below number, which is the 2, divide 1 by 2, you get exactly 0.5. Now, these two things represent the same fraction. This one over here is called a vulgar fraction, and this one here is called a decimal fraction. I know this one here, we just call it fraction, and this one here, we just call it decimal. But they are both fractions. Now, if we cut the cake in 4 equal parts, now one part here will be 1 out of 4. Again, that's a vulgar fraction. If you divide a 1 by 4, you get exactly 0.25. It terminates. It works out. And then if we cut the cake in exactly 8 equal parts, then one part will be 1 out of 8. If you divide the numerator by the denominator, you get exactly 0.125. Now, both of these, as I said, are fractions. This one here is called a vulgar fraction, and this one is called a decimal fraction, even though that's not what we normally call them. Now, the format 1 over 8, or 1 over 4, or 1 over 2, is called a vulgar fraction from the Latin word vulgaris, meaning the math that the common people use. Both the numerator and denominator are not zeros. Now, some vulgar fractions work out to be terminating decimals, as we see here. This half, which is a vulgar fraction format, works out to be 0.05, which terminates, and so with the quarter and the 1/8. Now, if we cut this cake in exactly 3 equal parts, I'm not going to show you that, but let us say we cut it in 3 equal parts, then one part will be 1 out of 3. Now, that's a vulgar fraction. If we divide the numerator by the denominator, 1 by 3, we get 0.3333 forever. It never ends. In other words, it does not terminate. It recurs. If we cut it in exactly 7 parts, then we'll have 1 out of 7. That's the vulgar fraction. If we divide the numerator by the denominator, we get 0.142857, 142,857, 142,857, and so on. And it keeps recurring forever. So now we have a recurring decimal. If we do the same thing with 55, 1 out of 55, if you try to divide 1 by 55, we get 0.01818181818 forever. Now, these vulgar fractions, if you divide the numerator by the denominator, and they do not work out, they are called recurring decimals. Now, many vulgar fractions work out to be recurring decimals. There are a few that work out to be terminating decimals, like half and quarter and 3/4. So if we were to include the negative numbers with W, we already did this, we have Z, which is an integer. Now we will return to the diagram and put in those fractions. If we include the fractions with this Z group here, if we include it, we now have fractions that are terminating and recurring decimals. So that this new group is called Q, and it is called rational numbers. Fractions that are terminating and recurring along with integers. So Q will be this big white group here that includes everything there. So Q is rational numbers, which includes fractions that are terminating and recurring, as well as the integers, which includes the whole numbers, which includes the natural numbers. Now, finally, in this lesson, there are some fractions that cannot be expressed as terminating decimals nor as recurring decimals. For example, later we will meet a quantity called pi, which expresses the ratio of the circumference of a circle to its diameter. You may already know that as 22 to 7 or 22 over 7. Now, if you try dividing 22 by 7 on this computer that I have here, I will get this 3.1415926535897 and so on, with nothing recurring or terminating. Nothing. Or if you find the square root of 2, you will get 1.41421356237 and so on, with nothing recurring or terminating. Now, funny thing is that these numbers here, that when you try to divide the numerator by the denominator, it does not terminate, nor does it recur. All such numbers are called irrational numbers. All such fractions are called irrational numbers. So at this point, irrational numbers are given the symbol F, and your syllabus defines irrational numbers as a number that cannot be represented as an exact ratio of 2 integers. And the examples your syllabus give are pi and the square root of 2. So if we were to put all the numbers that we have studied so far in a box, we will now have what is called real numbers. And real numbers are made up of the rational numbers over here and the irrational numbers on this side. So real numbers are made up of those two sets of numbers. Of course, rational numbers, Q, we have fractions and terminating and recurring decimals. Included in that is integers, and included in the integer group would be the whole numbers, and included in the whole number group would be the natural numbers. So most of our work will be done in Q, this section here, which includes W, Z, and N. Note that N is a subset, that expression there is read as subset of W. That is to say, everything in N can be found in W. And W is a subset of Z. Everything that can be found in W can be found in Z. Of course, the other way around is not true. Everything that can be found in Z cannot be found in W nor N. And Z is a subset of Q. Z is a subset of Q, which is a subset of R, real numbers. Of course, F is not a subset of Q. Now, all the numbers we have discussed so far can be located somewhere on the traditional number line shown above that you probably learned in grade 3 or 4. These are all real numbers, even if most of them are irrational. Now, there is also a complex number system making use of imaginary numbers, which do not concern us at this level of mathematics. How much of this do you remember? Let's test your knowledge. 8. What's the smallest group we could fit that into? Well, natural numbers. 25, natural numbers. 0, whole numbers. Negative 56 should be integers. Negative 2 should be the same as that one above there. 3/4. Now, this is a terminating decimal, so it would be Q should be rational numbers. 22/7, it will not terminate. It's an irrational number. Negative 0.85 should be Q, rational numbers. And 0.333, which will also be rational numbers. So we looked at sets of numbers based on historical discovery and usage. In this video, we group numbers in terms of their historical discovery and usage. And this brings us to the end of video 1 of 4 videos based on objective 1 from section 1.